I want you to think about the internet for a second, the one you use every day. Google, YouTube, your favorite social media site, even your local news blog. We call that the surface web. It's the stuff a search engine can find and index, like a giant public library with perfect cataloging. Here's the thing though, the surface web is tiny. It's maybe 5% of the entire internet. Everything else, that's the deep web. Now don't panic. The deep web isn't some sinister secret basement. You're actually on it every day. When you log into your bank account, when you check your email, or when a university accesses its private research database, that information is hidden behind a paywall, a login screen, or a password. It's not indexed by Google because Google shouldn't be able to read your private email. That is the deep web, private, protected, and totally normal. It's the bulk of the internet, and thank goodness for that privacy. But deep within that deep web, there is a distinct, small, and intentionally hidden corner. That, my friends, is the dark web. It's not just unindexed. It's actively anonymized, engineered to be hidden. It's the digital equivalent of a secret clubhouse where everyone wears a mask and the front door changes location every hour. The question isn't, is the dark web evil? The question is, how in the world does this part of the internet manage to hide itself so effectively? The answer is a piece of networking genius called onion routing. The whole system that powers the dark web is built on a network called Tor, which stands for the onion router. And I mean that name literally. Imagine you have a top secret message you need to send from my house to a friend across the country. If I just put it in a regular envelope and mail it, everyone along the route, the post office, the truck drivers, the sorters, they all know where it started and where it's going. They can trace the path easily. Tor doesn't do that. Tor wraps your message, your data request, in multiple layers of encryption like an onion. For my message to travel, I pick a random path of 3 different volunteer-run servers called relays from a worldwide network. Here's the brilliant part. I encrypt the message for the final destination, then I wrap that with another layer of encryption for the second relay. Then I wrap that with a third layer of encryption, but this time, the outside layer only tells the first relay, hey, open this layer and send the whole package to relay 2. When the first relay gets my message, it peels off the outermost layer. All it sees is send the rest of this encrypted blob to relay 2. It has no idea who I am, where the message is ultimately going, or what the message even is. Its job is done. Relay 2 receives the blob, peels off its specific layer, and only sees send the rest of this encrypted blob to relay 3. Again, it doesn't know the origin or the destination. Finally, relay 3, the exit node, peels off the last layer of Tor encryption. Now and only now does the actual original message appear. This exit node sends the message to the final destination, say a regular website. To that website, the request looks like it came from the exit node, not from me. Do you see the magic? No single node in the Tor network knows both the source me and the destination the website. The source is separated from the request by multiple layers of encryption and random hops. That is the fundamental principle of anonymity on the dark web. And it's why it was initially developed by the U.S. Naval Research Laboratory for Secure Government Communication. Imagine that irony. If you open the Tor browser right now, which you can legally download and use, and try to type in google.com, your traffic will be routed through that multi-hop onion circuit, but you'll end up on the regular Google website. So how do you find the hidden part of the internet? That's where the .onion domain comes in. Onion addresses are completely different from our familiar .com, .net, or .org. They are not registered through a central authority like ICANN. They are long, random-looking strings of letters and numbers like dusk gagild kier shur 60.onion. These addresses are generated cryptographically from a server's public key. This means that to access an onion site, you have to know the exact address, or you have to find a directory that lists them. These sites are called onion services. The server hosting the website is just as anonymized as the user accessing it. When you try to connect to an onion service, the connection doesn't just go from you to the server, Tor, it uses a 6-node circuit, 3 from the client side and 3 from the service side, meeting at a randomly chosen rendezvous point. It's like me sending a secret note to a restaurant and the restaurant sending a secret reply to a park bench. We never know each other's home address, only the next point on the map. This double layer of anonymity is what makes tracing the identity of a dark website administrator incredibly difficult. It's also why the dark web is noticeably slower than the surface web. Would you prefer speed or total multi-layered anonymity? It's a trade-off. When most people hear dark web, their mind goes straight to a black market selling illegal goods, and for good reason. They exist, and they are notorious. These sites, often called dark net markets, are simply e-commerce sites, but they trade in things like illicit substances, stolen data, and hacking tools. And they almost exclusively use cryptocurrencies like Bitcoin to facilitate anonymous transactions. But the dark web isn't just criminal marketplaces. That's a massive simplification that misses the whole point of the technology. Remember, the goal of Tor is anonymity. Who needs total anonymity the most? Political dissidents. People living under authoritarian regimes use it to communicate freely, organize protests, or access censored news without fear of government surveillance. Journalists and whistleblowers, people risking their lives to expose corruption, rely on Tor to submit documents and communicate with sources safely. For example, major news organizations like the New York Times maintain an official .onion service where sources can securely submit tips. Privacy advocates, regular people who believe their right to privacy is paramount and who don't want massive corporations tracking their every click, use it. The dark web is a pure manifestation of an idea that everyone has a right to communicate privately without surveillance. The unfortunate reality is that any tool built for perfect privacy can and will be used by criminals. A kitchen knife can prepare a gourmet meal, or it can be used in a crime. The technology itself is neutral. It's the intent of the user that defines the space. I want to debunk a few things you might hear on the news or see in a movie. Myth 1. The dark web is a separate hidden network of servers. Fact. The dark web runs on the exact same physical internet infrastructure, the same fiber optic cables and routers as the surface web. It's just how the data is routed and encrypted that makes it invisible. It's an overlay network, not a separate physical layer. Myth 2. Everything on the dark web is illegal. Fact. We just covered this. It's not. There are discussion forums, chess servers, and even legal literature archives down there. But here's the caution. Even visiting certain sites can expose you to malware, scams, or other dangers because the space is essentially unregulated. The security you gain from anonymity is countered by the danger of an unpoliced neighborhood. Myth 3. The FBI can't touch it. Fact. Law enforcement agencies and intelligence services actively work on the dark web. They use sophisticated techniques to de-anonymize users and operators, sometimes by exploiting a vulnerability in the Tor software itself, or by operating their own exit nodes to monitor traffic. They can run their own sting sites to gather evidence. The anonymity provided by Tor is strong, but it is not absolute. If you make a mistake, a tiny slip in security, a moment of real-world identification, the onion peels back and the protection is gone. When you strip away the sensationalism and the scary headlines, the dark web is one of the most compelling engineering achievements of the digital age. It's a testament to the power of cryptography and decentralized networks to give the individual a measure of privacy that the public internet simply cannot. It was created to protect the vulnerable, to defend digital human rights, and to fight censorship. But it stands as a perfect double-edged sword, a shield for the innocent and a cloak for the criminal. The mechanics are simple yet ingenious. Multiple layers of encryption and random routing ensure that the conversation is private, separating the identity from the communication. So the next time you hear the term dark web, I hope you remember the onion. I hope you remember the math, the encryption, and the volunteer nodes that keep this massive, secretive part of the internet alive. It's not magic. It's not science fiction. It is pure, complicated, often ugly and deeply important network science. It raises a powerful question for all of us. In an increasingly monitored world, where do we draw the line between necessary security and fundamental digital freedom? Let me know what you think in the comments. Have you ever considered the sheer scale of the deep web? And what responsibility do the creators of such powerful anonymous technology have for how it's used? Hit that like button and subscribe for more deep dives into the science of the world you think you know.